Okay, we are live on YouTube.
Hi, everybody, and welcome to Tech Talk Tuesdays. Today, we're presenting tips and tricks with GRDS, and I'm joined by Rich Murray. How are you doing today, Rich?
I'm doing well, Don. Good to be back in the booth with you on Tech Talk Tuesday. And of course, I mean, by booth, I mean my basement.
Yeah, I'm coming to you live from the bedroom today. So, this is kind of a companion piece to one that we've done a few weeks earlier with debugging with Colleague Studio. So I kind of think of that as being the first one where you would do some debugging, and then once you get things into the system and you have problems or you need to see things, this is what you would use to go out and take a look at those things.
I also like this one because as a companion piece to the debugging, because debugging was all in Colleague Studio, and this is pretty much all in UI. So this is available for users to interface with as well as programmers.
Right, right. So I wanted to say one thing about Ferrilli before we started. It's one thing to stand by your work. We guarantee ours here. When you hire extremely competent professionals who are dedicated to customer success, a guarantee like ours is easy to make. At the end of the day, customer satisfaction is the only thing that defines our success. Visit Ferrilli.com today to learn more about us. So I'm going to jump right in here. Basically here, we're just going to talk about our agenda. And we're going to talk about what GRDS is. And this consists of three things here: system integrity checking, diagnostic logging, and the GRDS services. We'll also talk about using GRDS free information, and that's turning logging on, making service requests, turning the logging off, reading the log file, and using GRDS custom information. So access to Colleague Studio for affected processes and entering the ShowA command and additional steps on GRDS. So some of these screens might seem new to you. If you're a developer, you've probably seen some of these things before. So we'll kind of go through them briefly with the GRDS introduction to the system integrity checking here. Oh, and we're also going to show some useful setups and tips at the end here that can help you with some different scenarios that you might want to look at. So what is GRDS? So this stands for the Generated Runtime Diagnostic Services. And there's two different runtime functionalities here that are included in the system. It's a system integrity checking that's continuously performing integrity checks on all envisioned programs that are running in the system, and it's always active. This is something that some of you may have seen before. I actually have a little example of this that I'm going to bring up real quick on my screen. You'll see here some thrown errors that you'll see on this UI here. This is a good example of that system integrity checking that's happening. You can see here there's a couple of sessions that have expired or a log out immediately. Those are just a couple of examples from test environment there. So that's where you would see those. So it's diagnostic logging. So we also have an on-demand feature. We can turn things on and off in here. So we can look at forms and see integrity checks based on how we set that up. We'll talk a little bit more about that. So kind of diving into the system integrity checking a little bit. It uses what's called triggered assertion checking. And this is really what, if you've been using Colleague for a long time, you remember that a lot of the old Colleague programs from a long time ago, Rich and I remember this, there really wasn't anything that told us a lot. I mean, we were really relying on the operating system for a lot of our checking of errors and things. Well, with the with the implementation of Envision and the case tool, there's code that's wrapped around all of the Envision processes that actually log errors. So they go into the UT thrown errors file, and that example that I showed you just a little bit earlier on that screen is really just output into that file. You can see those on those forms. I want to talk about the set confirm level a little bit. In the login paragraph in Colleague, which your system administrator would set up, that can be set to either 0, 1, or 2. 0 would be the lowest, and that would show the least amount of errors, and 2 would be the greatest amount of checking. You can also set this by hand on that SSCL screen. So that's a good thing to check before you start, is get that thing up to 2. So let's talk a little bit about diagnostic logging as well. So this is on demand. So this is where you would set this up. We'll show you some of these forms where you can set this up for your process so you can turn it on and off. This is backward compatible. If you remember the old DataTel debug inserts that used to be around, where you'd put CRTs and different things like that to display errors or comments in your code that you would see. It is backward compatible. However, I would suggest that you use the new ShowA and ShowC commands in your code rather than go backwards. But this is good because there are some old Envision programs out there that still use this, and I'm sure there are some custom in your environment that may use this if you've been a Colleague client for a while. GRDS services, and we'll talk about these, just turning on and off the logging and setting up your services set. So I mentioned this later on in the presentation, but the Envision Runtime Administration Manual is really invaluable here to see all your different service sets that you can use and what's turned on by default here as well. And here we have the valcode table that we'll talk a little bit about here. So if you need to see what those services are, like in your valcode table, you can see it there, GRDS services, and just pull that up. But like I said, it's also in the manual where it explains it a little bit more in detail. And this is your trigger mechanism for requesting these services. You specify the services you want to activate for each process. I'll turn it over to Rich here.
Yeah, that's a good segue into how to use the GRDS system. And I started off with what I consider free information, meaning if you're a programmer, if you're an Envision programmer, you don't have to do anything special to your code in order to be able to get this information, or your users to get this information. This is all part of generating a process that this is all included. So the first step to using the generated runtime diagnostic service is in UI, you will access a form called GRS1. This turns on Envision Diagnostics. You can see here that there's a service request set that you fill in, as well as the name of the log file where all this information is going to be placed. When you enter a brand new service request set name, it will automatically detail you to the GRSS services set form, where on the service request section, you use the syntax method for defining what you want to see in the log file. So in this example, there are 3 processes. So the first part of the syntax method is the process name, then a slash, a forward slash, and then the request codes that you want to see logged. So AE stands for arguments at entry, AX arguments at exit, process entry, and process exit. The second one, you can see there's a process name there, and then the / and a star. That means you're requesting every service GRDS has. Can be a little information overload, but sometimes you don't know what the programmer has put in, and so doing a asterisk gets you everything, and then you can refine it later. Optionally, on any service request row, you can detail to the GRDS form, services detail, and it kind of breaks it out into individual sections. So the top half of the form is the process name or the scope, and then the specific services you request individually. And you can see for the XFAF 602, we have arguments at entry, arguments at exit, process entry, process exit on individual lines. So you've turned logging on. Now you have to run the process to reproduce whatever issue that is. If it's a UI form, you need to go to that UI form, run the process. If the issue is on a particular field, you need to make sure you process through that field on the form. If it's a report or batch process, you need to kick off the front end form, provide the information there, and run that process through to completion. If it's a subroutine, that gets a little bit more difficult. You have to execute the process that calls the subroutine in order to see the subroutine log file. After you've run the process, you're ready to turn logging off, and that is done by the form GRS0. That's not an O, that's a 0. It automatically turns logging off, and then it brings up the log file, which you can then detail to take a look at what was actually logged.
Yeah, that's right. So, you can detail in there, and what I usually do is I'll detail in there and I'll just grab all of that out of there, just select it all out and then put it into maybe a text editor to take a look at. That's just a tip from me.
Yeah, I will also increase the font size so I can read it.
Exactly.
That might be an old guy tip, though.
Yeah, I think it is. But it's also stored in the log file. It's also stored in that PH directory under app home as well. You can see that it's prefixed with an O underscore. So you can see for the one that we created there, it has my username, the log file that I set up actually there in that second field, the name of the log file. But yeah, so it's sitting in there. If you need to go out and get your systems administrator to get it. If you forget to, sometimes it does happen that you just click cancel and you need to go back out and get it. It'll be out there for you. So this log file consists of 3 parts. Runtime information, the environment, the services requested, and then the diagnostics text. Kind of take a look at this real quick. Let's take a look at that runtime information. It's up at the top there. You can see the environment information there. You can see that it's a Unix environment here, and it's using Unidata 8.1. And you can also see what UDT options are on there. And a little further down in the log, you'll see what services were defined when we set this up on GRSS, and the processes and subroutines forms that you've defined in there as well. And then the diagnostics text follows that in detail. And that is, depending on what you've selected, like we talked before, is going to be either a little bit or a lot of stuff, especially if you've put that asterisk in there. So how do we read this file? Every line begins with a call chain prefix. So you can kind of see that, You know, you see the different services requested there, AD for your argument. You can see that it kind of goes through this chain. This gets more in depth, and there's more talking about this in the Envision Runtime Administration Manual. But you can kind of see just how it goes through the process here. It's numbered on the side. So the chain prefix is either a slash or a pipe character. That backslash indicates the call chain is getting larger, and the forward slash indicates that the chain is getting smaller as it goes down. So it kind of just flows through your code the way that the process runs. And again, you can see that service code there to the right of the brace there. You'll see that AD is the example there for that argument. So these can be a little bit tough to read, especially if you turn it all on. You're going to get probably, you know, you'll see that thing pop up with like 800 pages or something, or 600 pages, but don't be alarmed. If you know what you're looking for, get this thing into a text editor. We can start searching around with some finds and find the place where you need to take a look. And like I said, again, refer to the Envision Runtime Administration Manual here for some more in-depth instructions on reading the log file. I'll turn it back over to Rich here.
All right, so we know how to use GRDS in general. We go to GRS1, we turn it on, we request our things of the processes that we want to see. That is all well and good, but what if as a programmer, I want to see something that I can't get to, or I want to track a variable throughout my program? You can program custom diagnostic information using the ShowA command. So before you turn your diagnostic stuff on with GRS1, go into Colleague Studio for whatever process it is. I just chose, pretty standard s.get.email.address, and anywhere you want, enter ShowA and then the variable or variables that you want to see in the log file. So you can see here I did two of them, v.id and v.person.email.address. And then I also did a multi-valued one, ShowA al.addresses. Anywhere you want. So this is subroutine code. This is going to be on the code page, but this could be any hook in a UI form. This could be anywhere in a report process. Anywhere you want to see something specific, throw in a ShowA. Then to see what you programmed with the ShowA appear in the log, you have to add the number 1 to the services list. So in this example, I've gone down to GRSS. I've indicated my process name, s.get.email.address. I got the arguments at entry, process entry, process exit. I have to do the number 1 as my service request in order to see anything I programmed with a ShowA. So there are a couple of variations on the ShowA. There's the ShowA at, and then N standing for a numeric value between 1 and 9. So if I do a ShowA and a ShowA space at 1, that's the same thing. So ShowA at 1 can be shortened to just ShowA. If I wanted to do more detailed debugging, I could do a ShowA at 2 or a ShowA at 3. In order for those to get logged, the corresponding N value must be on that services list. The numeric values are cumulative. So if you add 3, for example, to the service list, then what you'll see logged is anything programmed in your code with a ShowA, ShowA at 2, and ShowA at 3. You'll get all of those ShowAs in your log file. There's also an option to use an alphabetical character between A and Z with the @ sign. In order to be logged, the corresponding alpha character must be in that service list. And the alphabetical characters are individual, which means if you've programmed something with a ShowA at M, for example, the only way you'll ever see that command end up in your log file is if you add the M to the service list. This is why sometimes it's nice to do the asterisk, because you don't, maybe you're a end user and you don't know what the programmer put in. Did they put in ShowA at 1, 2, 3, 4, 5? Did they do some alphabetical characters? If you do that asterisk, you'll get everything. You'll get all of them. So a couple of useful setup tips and tricks involving ShowA. I recommend if you're using internal subroutines, and just a side note, I highly recommend using internal subroutines for your code when you can. But log the entry at least into the internal subroutines as a general, like I at least got to this point in my code as you're developing that internal process. For UI forms, I think it's a good idea to indicate where you are processing in that form. So the field exit hook of students.id, and then do whatever variables you want to see in the log file, but indicate at what point you are processing that UI form. The ShowA stuff can be really useful for debugging inserts that you might be having a problem. This might be a custom insert developed by another programmer. This might be a delivered insert that seems to be acting differently, maybe after a software update. So the first step will be to import and check out that insert. Then in that insert code, throw in some ShowAs. I recommend using one of the alpha characters, like an @x in this example, and then do whatever you want to do with the ShowAs. You have full autonomy to throw in whatever you need to throw in. Put them all with a ShowA at X though, or keep the alpha character consistent. Once you're done entering your ShowA stuff in, export that insert and regenerate the process that uses the insert. Because remember, the GRDS system is a generated runtime diagnostic service, and you can't generate inserts. Inserts are included in a process, and then that process gets generated. So that's why you need to export the insert and regenerate the process that uses that insert. Final step, add the process that calls the insert to GRDS, and then use the X in the service list so that you'll see the codes that you put in to that insert using the ShowA at X. This is just a couple of the things. There are lots of cool variations on ShowA. If you look in the Envision basic commands reference, it'll be in the alphabetical section under S. There's ShowA and ShowC. There's some great stuff for doing associations, and the ShowA command to use for associations, indenting your commands. It's there's lots more stuff in there.
Yeah, I'm going to talk a little bit about WebAdvisor and the Web API and being able to use the same debugging mechanism there. It's a little different, some different forms that we have to set up to do that. So we're going to use the GWSC form and the GWSC2 form to set this up. So this one is a little tricky sometimes. What you need to do here is you need to specify that token that you get in your URL in WebAdvisor. or in your API. And you can see there that I put an example of a token ID that is in a WebAdvisor URL there. So in that GWSC screen, you're going to go into there and just put that token ID in that first field. You could also put some other things in there as well. So if you wanted to just, limit it to a date or the opera or, the time, basically you can go through here and pare it down as you like. And then what that'll do is, if you don't use a token, you could use other things as well. But the token is probably the best, because then you're going to end up with a lot of different sessions, perhaps. As you can see in that next form, in the GWSC form, excuse me, you can detail in there where that token ID is, and that will pull up the same log that we saw before with GRS 0. It'll show all of those things that happened during that WebAdvisor run. So some additional tips: don't request everything. I think we talked about that a little bit previously, and that's putting the star out there, or just the star, which you can do, and you will see everything, and it's going to be
you'll kind of walk into the Library of Congress at that point.
Yeah, exactly. So you're going to see everything. It's going to be a massive log file. You don't want to do that. Here's one that I think is very useful. Is you can take a look at your subroutine here. Say you have a subroutine that you think is throwing an error. If you put in this insert into your code, the thrown error insert, you can then sort of call your subroutine, and then, as you can see here, you are basically initializing the number of errors thrown previously. And then when you call your subroutine, then you're basically taking that and subtracting the old errors from the new errors that are thrown. And that'll show you the number of errors that your subroutine is throwing. So if you got one that you think is throwing some errors, or you want to see if any of them are throwing errors, you can just pop this around all of them.
Okay, the next couple of slides are just a bunch of already built sort of debugging things for, in this example, log a session's DMI traffic. If on GRSS you put DMI _ transmit / arguments at entry, arguments at exit, you can log a session's DMI traffic. There's another one for message codes. What is that error or warning code? So S _ get _ help message /1. That's using the ShowA. Remember the ShowA at 1, or just the plain ShowA. Then there's several lookups, and you can see that some of these use the alpha character. So Ellucian has built in some debugging diagnostic stuff using the ShowA at A command for some of these. So S _ SQL select, select list, lookup ID, parse, all that good stuff. There's a lot of things that are built into the diagnostics. Just got to know what to request. A couple more here. There's for selects and MeoCell. So this is what is occurring when you do a list specification. You can kind of see that get processed. There's execute statements. One of my favorites is s.proc.run /a. That essentially gives you what's on the procedure hook for a front end form. And then we've seen in the example, at least with the ShowA, whatever your subroutine is, I like the arguments at entry and arguments at exit as a big information piece, because it tells me if my subroutine is designed to calculate a value or return something based on a student's ID, I can see that argument coming in is null. And then at exit, what is the value at exit? So I really like those two.
That's a good one. So with batch processes, what is recommended is to just use the batch process and then an asterisk. So you're going to see everything. Of course, you can do some things there. You can change that around, play with it based on some of the other service codes. But usually when I do it, I just do an asterisk for it's a batch process. Like that. If you want to see the performance of your process, so you're going to use these performance request sets, the PE, AE, and ET. And this is another one that's useful. So if you like CRT, like a lot of old programmers do, CRTs in there, this is a good replacement for it. So basically, instead of CRT, you just do the call s_GRAS, and then put your code in there quoted. You can see it's concatenated onto a custom code there. And then finally here to see what's writing in your process. So you have two different options here. You can specify what you want to see writing. So if you see that top one, you're just going to look at everything that's writing in your process. So if you have a process that's updating records, you're going to see every single thing that's doing that. And then you have basically what you can do is define just one thing that is doing that writing. Like in this case, you have a subroutine here that's going to be looked at, and that's all it'll be looked at. So we had a few things here that we talked about today. Just in summary, here's a couple of good reference materials here. That's article on the Elution Hub. It has more setups and more tips that you can use. It's a great doc there. It's been out there for a while. And then the Envision Runtime Administration Manual. Both of those are going to give you some more information on how this system works. So Rich, this has been great. Enjoyed presenting with you again.
Always a pleasure. And actually, I mean, I use GRDS a lot, and all that stuff you covered in the beginning with the diagnostic information, brand new to me. That was awesome. I learned
great. Something. Yeah, I did too. Hey, thanks a lot. And if you have any questions about our solutions and services, there's our contact information. Please visit us at Ferrilli.com. Have a great day.
Have a great afternoon, everybody.